In these problems, we need to multiply, and in this case, we have roots that we're working with. So we need to follow the product property of roots. The main thing to know is that unlike with addition and subtraction, the roots do not have to be the same. Instead, the roots, in terms of they have to both be square roots or they all have to be cube roots or what have you, but the values inside of them do not have to be the same. You just multiply the values inside. And then, if applicable, when you're done, you go ahead and simplify. So for the first one, we have the square root of 8 divided, or the square root of 8 times the square root of 3. So I can write that as the square root of 8 times 3. Well, that becomes the square root of 24. Okay, now the square root of 24, I now look and see, is there a perfect square that goes evenly into 24? And there is. 4 goes into it, so I can go ahead and simplify. So now I get 4 times 6. So that becomes the square root of 4 times the square root of 6. Well, the square root of 4 is 2, square root 6. So that is your final answer. Okay, the next one we have parentheses 4 square root 3 times parentheses 5 square root 2. So the only difference here is that we now have values in front of the roots. So we need to multiply those first. So 4 times 5, which is 20. And then square root the values on the inside multiplied, which is 3 times 2. Now we combine the 3 times 2, so we get 20 times the square root of 6. And then again we ask, is there a perfect square that goes into 6 evenly? There isn't, so this is my final answer. All right, for this next one, we're going to have to use distribution like we've used before. We have a square root of 2 on the outside, and then we have 2 terms on the inside of the parentheses. So the first thing we need to do is multiply the square root 2 by 3 root 2. Well, this time there's a 1 out here, so we do 1 times 3 to get the first value. Well, 1 times 3 is 3. Then we get the square root of 2 times 2. So we're done with that first term. Now we do plus 1 times 5, which is 5, square root the values on the inside multiplied, which is 2 times 8. All right, now I'm going to go ahead and combine under the root. So I get 3 square root 4 plus 5 square root 16. Now I can simplify both of those. I get 3 times 2, because the square root of 4 is 2, plus 5 times the square root of 16, which is 4. Okay, so my next step is to multiply. So 3 times 2 is 6, plus 5 times 4 is 20. So my final answer is 26. So notice I didn't end up with any roots at the end because everything simplified out to whole numbers. All right, so the next one, we have cube roots, and the key is that all of them are cube roots. So I can go ahead and distribute to everything. If they weren't all cube roots, then they would just end up sitting next to each other. I couldn't actually combine them. Okay, so like on the previous one, I've got a 3 on the outside. I've got numbers on the outside, so I need to multiply those first. So I get 3 times 2 is 6, cube root 4 times 2, and then 3 times negative 5 is minus 15, cube root 4 times 3. Now I go ahead and combine under the roots, so I get 6 cube root 8 minus 15 cube root 12. Okay, next I need to see, is there anything that can be simplified? Yes, the cube root of 8 is actually 2, so that becomes 6 times 2 minus Now, is there a perfect cube that goes into 12? Well, the smallest perfect cube is 8, and 8 does not go evenly into 12, so I know that I cannot simplify that root. So that's just going to stay the same. So minus 15 cube root 12. Okay, my final step is to go ahead and multiply the 6 times the 2, which is 12 minus 15 cube root 12. Now, because my first term does not have a cube root 12 connected to it, these are not like terms, so I cannot combine them. So the 12 minus 15 root 3, or cube root 12, so let me say that again, 12 minus 15 cube root 12 is my final answer. Here we have roots again that we're multiplying, but notice now we have binomials. So we need to do our distribution, or FOIL is what a lot of us are more familiar with. So I'm going to start out by multiplying my first 2 terms. So I get the square root of 2 times 2. Now I'm showing the intermittent step of the multiplication underneath the root. Eventually, as you become more comfortable with this, you may not need to include that. You could just go ahead and multiply the 2 times 2 and get the square root of 4. But I'm just doing it to make sure people are comfortable with what exactly we're doing with the product property of roots. Okay, just a side note. All right, so here we have the square root of 2 times 3. So I'm going to get plus, and I'm putting the number first, the coefficient first, 3 root 2. Now I have 3 times root 2, so that's another plus 3 root 2. And then 3 times 9, which is plus 9. Now, the square root of 2 times 2 is the square root of 4. Well, the square root of 4 is 2, so I can just go ahead and write that. Plus, I can combine these because the root 2's are identical. So I get 6 root 2, and remember, when you're combining using adding and subtracting, the value in the root does not change. That only changes with multiplication and division. Okay, so I'm done with my middle terms, plus 9. Now I'm still not quite done because the 2 and the 9 can be combined. So my final answer is going to be 11 plus 6 root 2. Okay, so let's go ahead and do another one. This one just has a few more roots in it. Okay, so we have 5 times negative 3, which is negative 15. Now I multiply the inside. I'm going to go ahead and not do the intermittent step of showing the multiplication. So I have the square root of 2 times the square root of 3, which is the square root of 2 times 3, which is 6. So that takes care of the first one. Then I have 5 times negative 4, which is negative 20. Square root 2 times 6, which is 12. Now I have a minus times, or a minus 1 times negative 3, which becomes positive 3. And then I have the square root of 3 times the square root of 3, which is the square root of 9. And then I have negative square root of 3 times negative 4 times root 6. So here I have negative times negative 4, or negative 1 times negative 4, which is plus 4, square root 3 times 6, which is 18. All right, now I need to see if there are any things that I can simplify or combine. Right now there's nothing I can combine because there are no common roots. The first one, there's no perfect square that goes into 6, so that one's fully simplified. So I have minus 15 square root 6. Now root 12 can reduce because a 4 can go into that. So I have minus 20 square root 4 times the square root of 3, right? Because 4 times 3 is 12, plus 3 times the square root of 9, which is 3, plus 4. Now I can simplify square root of 18. That becomes the square root of 9 times the square root of 2. Okay, so again, the first term I can't do anything with, minus 15 root 6. Now this 4 can come out, and remember anything that comes out gets multiplied by the value in front. So the square root of 4 is 2, so I get negative 2 times 20, which is negative 40, and then that root 3 comes down, plus 3 times 3, which is 9, and then plus, well, the square root of 9 is 3, so 4 times 3 is 12, root 2. Okay, now I look and see, are there any common terms that I can combine? Well, I have a root 6 in the first term, a root 3 in the second, and a root 2 in the fourth. So none of those can be combined. And then I have no other number by itself. So that 9 is going to be staying put. So this is my final answer. I cannot combine anything else. Here we're multiplying again, but these are written as perfect square binomials. So you have to remember to expand them before you're able to do anything else. So to expand, I'm going to do the square root of 3 plus 2 root 5. And then I'm going to multiply that by another one because it's a square. That's what that exponent tells me. Plus 2 root 5. And now I have to do my FOIL, or the distribution. So I get the square root of 3 times the square root of 3. That's the square root of 9. That's this first multiplication. Square root of 3. So I've got a 1 in front of here. So I'm going to start with the numbers. So 1 times 2 is 2. Square root of 3 times the square root of 5 is the square root of 15. Plus 2 times 1 is 2. Square root of 5 times square root of 3 is square root of 15. Plus 2 times 2 is 4. Square root 5 times 5, which is 25. So again, here I didn't show that intermittent step of the multiplication. I just went ahead and combined them under the roots. Okay, so is there anything I can simplify and combine? So the square root of 9 is 3, plus we have 2 plus 2, and these roots are the same, so I can go ahead and combine them. So plus 4 root 15, that takes care of my middle terms, plus 4 times, well, the square root of 25 is 5, so that can simplify down. My next step is to recopy the 3 plus 4 root 15 plus 20, 4 times 5. And now 3 plus 20 is 23 plus 4 root 15. And then you want to double check, is there a perfect square that goes evenly into 15? And there isn't, so that is my final answer. And again, it's a perfect square that I'm looking for because that is a square root. I'm just rewriting that so we can read that. There we go. All right, and the next one, that's also a perfect square binomial. So we need to do the same thing where we write 2 of these. 4 cube root 5 minus 2 cube root 2. And I'm going to write a second one to, again, incorporate that squared. So 4 cube root 5 minus 2 cube root 2. And now I do my FOIL. And what you might want to do is pause the video at this point, try the problem, and then watch the steps and see if you do them correctly. Okay, so my first step is to multiply the first terms. So I have 4 times 4, which is 16. Cube root 5 times 5, which is 25. Now I have 4 times negative 2, which is minus 8. Cube root 5 times 2, which is 10. Now I'm done with my first term and I go to my second. So I have minus 2 cube root 2 times 4 cube root 5. So minus 2 times positive 4 is negative 8. cube root. 2 times 5 is 10. I have a minus 2 times minus 2, which is plus 4. Cube root. 2 times 2 is 4. All right, now we want to look and see if there's anything that we can combine. Now here we're dealing with cube roots. So we need to think of cube roots, if there are any, that go evenly into 25. So we've got 8 is a cube root, 27 is a cube root. Do either of those, or a perfect cube, do either of those go into 25 evenly? The answer is no, so I can't do anything to simplify that one. So I get 16 cube root 25. Okay, now here I have a cube root of 10 and a cube root of 10. So those are the same. They are like terms, so I can combine them. So minus 8 is negative 16 cube root 10. That takes care of my middle terms. And then I have plus. Now, does any cube root go in evenly to 4? No, so I cannot simplify that one either. So I get 4 cube root of 4. And that is my final answer, as there are no other roots that are the same so that they can be combined and everything is simplified.